Hello and welcome to Sleep Science Space. Tonight we'll gently wander into a hidden kingdom that lives all around us yet is often overlooked, the world of mushrooms. Mushrooms are not quite plants and not quite animals, but something entirely their own. They breathe like we do. They grow quietly without sound, and they have been shaping life on Earth for far longer than forests have existed. Some mushrooms glow in the dark like tiny lanterns scattered across the forest floor. Others spread vast, unseen networks beneath our feet, weaving together the roots of trees in a silent exchange of signals and nutrients. Some appear in colors so vivid they look painted by hand, while others contain poisons so powerful that a single bite can be fatal. And yet, mushrooms are also builders, healers, and recyclers. They help bread rise and grapes ferment into wine. They can break down oil spills and plastic waste. They may even offer clues about how life could survive on other planets. Quiet, ancient, and endlessly adaptable fungi play roles that touch nearly every part of our world. If you enjoy these gentle science explorations, you're welcome to subscribe, or share a thought in the comments. It helps other curious minds find their way here. But for now, get comfortable, let your breathing slow, and allow your attention to soften. Let's begin. Mushrooms are more closely related to animals than to plants. This often surprises people. Although fungi grow in forests and sprout from soil like plants genetically, they are closer to animals, including humans. At the cellular level, fungi breathe oxygen and release carbon dioxide just as we do. Their cell walls are made not of cellulose like plants, but of chitin, the same durable material found in insect shells and crustacean exoskeletons. This shared ancestry places fungi on a hidden branch of life that we rarely consider. When you walk through a forest, mushrooms may seem to belong with leaves and flowers, but in reality, they are distant cousins of creatures that walk, swim, and fly. Knowing this can subtly shift how you see the forest floor, not as a plant landscape alone, but as a quiet gathering of relatives living side by side. Some mushrooms glow with their own natural light. Imagine walking through a dark forest at night and seeing faint green or blue glows shimmering in the moss. These softly glowing mushrooms produce light through a process called bioluminescence, the same phenomenon seen in fireflies and certain deep-sea creatures. More than 70 known mushroom species can glow this way, including one commonly called foxfire fungi. Scientists believe the glow may attract insects, helping spread spores farther through the forest. Others suggest it may discourage animals from eating them. The light is produced through a chemical reaction involving an enzyme known as luciferase, which releases energy as visible light. To encounter a glowing mushroom in nature is to witness something ancient and quiet. Light born from decay, a reminder that even as wood breaks down and returns to the soil, it can still produce moments of unexpected beauty. A single fungal network can stretch for miles underground. What we call mushrooms are only the visible fruiting bodies of a much larger organism. Beneath the soil lies mycelium, a vast network of thread-like structures that absorb nutrients and transport information. Some mycelial networks are so large they are considered among the biggest living organisms on Earth. Hidden beneath forests, these networks connect trees, plants, and soil into a living system that shares resources and signals. Long before humans built roads or communication lines, fungi were already creating networks that sustained entire ecosystems in silence. Mycelium is made of countless delicate, thread like filaments that spread quietly through the soil, wrapping themselves around roots, stones, and the remains of fallen leaves. These fine strands weave together into living networks that most of us never see. In some places, this underground web becomes unimaginably vast. A single mycelial organism can stretch across hills and valleys, connecting thousands of trees into one shared system. It is like a net of living threads hidden beneath the ground, silently at work beneath the forest floor. Through these networks, fungi recycle nutrients, transport water, and even help plants exchange resources with one another. Sugars, minerals, and chemical signals move from root to root, guided by fungal pathways. It is as if the earth itself has veins pulsing slowly with invisible life. When you walk across a field or a patch of grass, you may unknowingly be stepping on a single enormous organism, ancient, quiet, and everywhere at once. The largest living organism on Earth is a mushroom. In the Blue Mountains of Oregon lies something truly remarkable. On the surface, the landscape looks ordinary pine forests, streams, and open meadows. But beneath the soil lives the largest known living organism on the planet, a single fungal network belonging to Armillaria ostoyi, commonly called the honey fungus. This vast mycelium spreads across nearly 4 square miles and is estimated to be thousands of years old. Every mushroom that appears above the ground is just a small expression of this enormous hidden body. In terms of mass, this single organism outweighs even the largest blue whale many times over, and it has existed quietly for longer than most human civilizations. When scientists first mapped its true size, they realized that the forest above was not made up of countless separate individuals, but was instead growing atop one immense living being, a creature stretching silently beneath their feet, ancient and patient, thriving like a slow heartbeat within the earth itself. Mushrooms can communicate using electrical signals. Although fungi have no brains and no nervous systems, they are far from silent. Within their mycelial threads, researchers have detected tiny electrical pulses moving through the network. These signals resemble in some ways the electrical impulses that travel through animal neurons. Some scientists have observed patterns in these pulses that change in frequency and timing, suggesting they may carry information. Through this system, fungi may signal the presence of danger, the availability of nutrients, or changes in the environment to other parts of the network. It is almost like an underground internet woven into the soil, transmitting messages in a language we are only beginning to recognize. In this quiet exchange, trees may send excess sugars through fungal pathways to neighboring plants, with mushrooms acting as messengers and couriers. While this communication is not thought in the human sense, it is communication all the same, a reminder that intelligence does not require a brain and that the earth is alive with conversations we cannot hear. Some fungi can survive the conditions of outer space. When scientists began testing how life might endure beyond Earth, they included fungal spores in their experiments. The results were astonishing. Certain species survive direct exposure to the vacuum of space, intense radiation, and extreme cold. These spores remained outside spacecraft for weeks, protected only by their own natural resilience. When brought back to Earth, many of them were still alive and capable of growing. This extraordinary durability has made fungi intriguing subjects in astrobiology, the study of life beyond our planet. If fungal spores can survive such harsh conditions, it raises the possibility that life itself could travel between planets, carried by dust meteorites or cosmic debris. This idea, known as panspermia, suggests that life might spread across the universe far more easily than we once imagined. The humble mushroom, often overlooked beneath fallen leaves, may carry within it the ability to endure the silence of space and awaken again wherever it finds water, nutrients, and time. Mushrooms have been found growing inside nuclear reactors. After the Chernobyl nuclear disaster in 1986, scientists exploring the damaged reactor discovered something unexpected thriving in the radioactive ruins. Fungi, certain species, including Cryptococcus neoformans, were not only surviving in intense radiation, but appeared to grow toward it. These fungi contain melanin, the same pigment found in human skin. Researchers believe this melanin may allow the fungi to convert radiation into usable chemical energy in a process sometimes described as radiotrophic growth. In a sense, these mushrooms may be feeding on radiation, transforming something deadly into fuel. This discovery has profound implications. In the future, fungi could help clean up radioactive waste or even protect astronauts from cosmic radiation during long space journeys. In places where life seems impossible, dark, toxic, and dangerous mushrooms have found a way not just to survive, but to grow. Fungi can digest plastic and oil. One of the most hopeful discoveries of recent years is that certain fungi are powerful recyclers. Some species can break down plastics, petroleum products, and other pollutants that lingers in the environment for decades. Enzymes released by fungi can dismantle complex chemical bonds, turning waste into simpler compounds that return to the soil. In a world struggling under the weight of pollution, fungi offer a quiet form of healing. They do not demand attention. They simply work slowly and persistently, restoring balance molecule by molecule. Long after machines shut down and cities fall silent, mushrooms continue their ancient task of transformation. Certain fungal species possess an extraordinary ability to break down materials that would otherwise remain in the environment for centuries, including plastics and petroleum based products. In 2011, researchers studying the Amazon rainforest discovered a fungus capable of consuming polyurethane, one of the most stubborn and widely used plastics in the modern world. Other species have demonstrated the ability to digest crude oil, slowly transforming toxic spills into substances that are far less harmful. It invites a quiet but powerful image. Landfills shrinking not through heavy machinery, but through patient fungal colonies working in darkness, breaking down waste molecule by molecule. Scientists are now exploring how these organisms might be used intentionally, designing fungal systems that could one day help clean polluted soil oceans and industrial waste sites. In a world increasingly overwhelmed by what we discard, fungi remind us that nature often already holds the tools for repair. We simply have to learn how to observe, respect, and work alongside them. There are mushrooms that can kill with a single bite. Among the wonders of the fungal world lies a darker truth. Some mushrooms contain toxins so potent that even a small taste can be fatal. The death cap mushroom, Amanita phalloides, is among the most dangerous organisms on Earth. Its toxins quietly attack the liver and kidneys, and symptoms often appear only after irreversible damage has begun. What makes it especially unsettling is its appearance: pale, unassuming, and easily mistaken for an edible species. Throughout history, poisonous mushrooms have claimed the lives of kings, peasants, travelers, and entire families who had no idea of the danger before them. In the fungal kingdom, the boundary between nourishment and poison can be razor thin and nearly invisible, yet even this danger carries a kind of awe. The idea that something so delicate in appearance can hold enough chemical power to end a human life is a reminder that nature, however beautiful, is never harmless. It demands attention, humility, and respect. Other mushrooms taste remarkably like lobster or chicken. Not all fungi bring risk. Some bring unexpected pleasure. Certain edible mushrooms possess flavors and textures so convincing that they resemble meat or seafood with astonishing accuracy. The lobster mushroom, with its vivid reddish orange surface, carries a rich savory flavor often compared to shellfish. Chicken of the woods grows in layered fan-shaped clusters and tears into fibrous pieces that closely mimic the texture and taste of chicken breast. Long before plant-based diets became popular, foragers valued these mushrooms as natural alternatives to meat. To taste them is to encounter the strange adaptability of fungi. How something that grows quietly from the side of a tree can evoke the flavors of farm or sea. Mushrooms seem to borrow tastes from the animal world while remaining entirely rooted in their own mysterious domain, as if they are shapeshifters of flavor, reflecting life in unexpected ways. Ancient cultures used mushrooms in sacred rituals. For thousands of years, mushrooms have played roles far beyond food. Across ancient cultures, they were woven into spiritual practices, ceremonies, and myths. From Mesoamerican civilizations to Siberian shamans, certain mushrooms were believed to open doors to the unseen, offering visions, insight, or communion with the divine. These cultures viewed mushrooms not merely as organisms, but as intermediaries between worlds. Growing suddenly after rain appearing and disappearing without warning, they seemed to embody transformation itself. Whether used for healing prophecy or ritual, mushrooms were treated with reverence and caution. Their power was acknowledged, not controlled. In this way, fungi have long stood at the crossroads of science, survival, and spirituality. Quiet teachers emerging from the soil, reminding humanity that knowledge does not always arrive through force or noise, but sometimes through patience, observation, and respect for the living systems that surround us. To ancient peoples, mushrooms seemed to arrive as if by magic. One day the ground was bare, and by the next morning strange shapes had risen from the soil fully formed. Appearing without seeds, without flowers, and without warning, fungi felt less like ordinary life and more like visitors from another realm. In Siberia, shamans used the red and white Amanita muscaria, the mushroom now forever linked with fairy tales, to enter trance states during sacred rituals. Across Mesoamerica, the Aztecs revered certain mushrooms as Teonanacatl, meaning the flesh of the gods. These fungi were consumed in ceremonies meant to open pathways to the divine, allowing participants to receive visions, guidance, and insight beyond the everyday world. Even in ancient cave paintings in Spain, believed to be over 6,000 years old, figures appear holding mushroom like forms, suggesting that humans have long seen something extraordinary in these organisms. To our ancestors, mushrooms were not simply food, they were gateways, sudden messengers emerging from the earth, blurring the boundary between the physical world and the unseen. Their unpredictable nature made them symbols of mystery transformation and the thin veil separating ordinary reality from something deeper and more profound. Some mushrooms can take control of the minds of insects. Among the most unsettling wonders of the fungal kingdom are the cordyceps fungi. These mushrooms do not merely grow quietly in soil or wood. They infect living insects and slowly take command of their behavior. A microscopic spore lands on an ant, and over time, the fungus spreads throughout the insect's body, weaving itself into muscle and tissue. Eventually, the infected ant begins to act strangely. Driven by chemical signals, it climbs upward, gripping a leaf or stem at a precise height. There it locks its jaws and becomes still. Soon after, the fungus erupts from the ant's body, growing a stalk that releases spores onto the forest floor below, ready to begin the cycle again. This phenomenon has earned cordyceps the chilling nickname, the zombie fungus. While disturbing, this process reveals the extraordinary adaptability of fungi. Without eyes, brains, or muscles of their own, they have evolved ways to influence the behavior of other living beings with remarkable precision. Beneath the calm surface of the forest, silent dramas unfold, where insects become unwilling actors in a play written by spores and survival. A fungus once devastated amphibian populations worldwide. In the late 20th century, scientists began noticing a troubling pattern. Frogs, toads, and salamanders were vanishing across continents. Entire populations disappeared in a matter of years. The cause was eventually traced to a microscopic fungus known as Batrachochytrium dendrobatitis, often called BD. This fungus infects the skin of amphibians, a vital organ for them. Unlike humans, many amphibians absorb oxygen and regulate water directly through their skin. When BD disrupts these processes, the consequences are often fatal. The spread of this single organism has led to the decline or extinction of hundreds of species and is considered one of the most destructive wildlife diseases ever recorded. The rise of BD reveals a sobering truth. Fungi are not only healers, recyclers, and quiet collaborators in life's systems, they can also be powerful agents of destruction, capable of reshaping ecosystems on a global scale. Today, conservationists work urgently to protect vulnerable species, developing antifungal treatments and breeding programs to prevent further loss. The story of BD reminds us that fungi hold immense power, both creative and catastrophic. The air you breathe is filled with mushroom spores. Even now, as you rest and listen, invisible travelers drift through the air around you. Mushroom spores are everywhere, in forests, cities, oceans, and homes. Each breath carries countless microscopic seeds released by fungi across the planet. Most are harmless, many are essential, and a few have the potential to grow wherever conditions allow. These spores travel vast distances on wind currents crossing continents and oceans, waiting patiently for moisture, darkness, and food. It is through this constant unseen rain of spores that fungi maintain their presence everywhere on Earth, quietly, persistently, endlessly. A reminder that the fungal world is not distant or rare, but intimately woven into the air itself, surrounding us even as we sleep. With every quiet breath, you draw in fragments of a hidden world. Tiny fungal spores, far too small to see, drift endlessly through the air around you. They move through cities and forests alike, ride ocean winds, and fall softly with rain. Scientists estimate that in every single cubic meter of outdoor air, there may be thousands of these microscopic travelers. You breathe them in without awareness, and yet your body is well adapted to their presence. In fact, fungal spores are among the most common living particles in Earth's atmosphere. So light and fine are these spores that many rise far above the surface of the planet. They are carried upward into clouds, swept along by invisible currents. In this way, each breath quietly links you to distant ecosystems, to forests you may never walk through, to soils you may never touch. Even in stillness, you are connected to the wider living world by the silent circulation of fungi. Spores are built to travel where seeds cannot. Unlike seeds, which are heavier and bound to soil, spores are designed for motion. Many are so small they can remain suspended in the air for extraordinary lengths of time. Some have been detected high above Earth's surface, drifting in the stratosphere more than 20 kilometers up. There they catch fast-moving winds that circle the globe, crossing continents and oceans with ease. These spores are protected by tough outer layers that shield them from ultraviolet radiation, dryness, and extreme cold. This armor allows them to survive journeys that would destroy most life. A single spore released from a puffball mushroom in a quiet meadow might rise skyward, travel unseen for months, and eventually settle into soil on the far side of the planet. Through spores, the atmosphere itself becomes a living highway, endlessly connecting distant landscapes. Some fungal spores can even endure the conditions of space. In laboratory experiments, scientists exposed spores to the vacuum radiation and temperature extremes beyond Earth's atmosphere. Against expectation, many survived. Sheltered within their resilient shells, spores endured not just minutes, but weeks outside spacecraft, clinging to satellites or floating freely in orbit. This remarkable durability has fueled ideas like panspermia, the possibility that life might spread between planets carried by dust meteorites or microscopic organisms. If fungal spores can withstand the void, it suggests that life itself may be more mobile than we once imagined. When you watch a mushroom release a faint cloud of spores into the air, you are witnessing a strategy so effective it may reach far beyond our world. Tiny explorers released in vast numbers, waiting patiently for a place where life can begin again. Mushrooms can even reshape stone itself. Rock may seem permanent, but over long spans of time, even stone yields to fungi. Certain organisms, known as lichens, partnerships between fungi and algae, slowly dissolve rock by releasing mild acids. Grain by grain, mineral by mineral, solid stone is broken down and transformed into soil. Over centuries, this process helps carve mountains, soften cliffs, and create the foundation for plant life. Without fungi and lichens, much of Earth's surface might remain bare and lifeless. In this sense, fungi were among the planet's earliest gardeners, quietly preparing the ground for forests, grasslands, and eventually animals. Even today, on ancient ruins, weathered statues, or old gravestones, you can see their work. Faint stains and delicate patterns etched into stone, shaped not by force, but by patience. With timescales measured in centuries rather than moments, fungi remind us that persistence can be more powerful than strength. Some fungi leave mysterious circles known as fairy rings. In open meadows and grassy fields, you may notice perfect or nearly perfect circles of darker, thicker grass. These formations, called fairy rings, are created as underground fungal networks expand outward year after year. As the mycelium grows, it releases nutrients into the soil, enriching the grass at its edge while exhausting the center. To earlier cultures, these rings seemed magical. They were said to mark places where fairies danced or spirits gathered under moonlight. Today, science offers an explanation, but the wonder remains. Beneath a simple ring of grass lies a living circle, slowly widening, with time tracing the quiet expansion of a fungus beneath the earth. Step into a meadow after a gentle rain, and you may notice something quietly extraordinary. A ring of mushrooms, almost perfectly circular, rising from the grass as if carefully placed. These formations are known as fairy rings. They appear when a single fungal organism grows outward beneath the soil, expanding evenly in all directions year after year. The mushrooms themselves are only the visible edge of this growth, brief signals of a much larger life hidden below. As time passes, the ring slowly widens. In some fields, these circles grow larger each season, tracing the patient expansion of the fungus beneath the ground. Long before science offered an explanation, people saw these rings as magical signs. Folklore described them as places where fairies danced at night portals to unseen worlds or boundaries no human should cross. Today, we understand the biology behind them, yet the sense of wonder remains. To encounter a fairy ring is to see geometry alive, a perfect shape drawn not by hand, but by living threads moving silently through the earth. Mushrooms are also famous for how suddenly they appear. One day the forest floor looks empty. The next morning, New forms stand where there were none before. Some mushrooms can push their way up through soil and leaves in a matter of hours. This rapid growth is made possible by the mycelium beneath the surface, which has been gathering nutrients for long periods of time. When rain arrives and conditions are right, the stored energy is released all at once. Moisture softens the ground temperatures, shift, and the mushroom rises. Caps unfold, stems stretch. What looks like a miracle is the result of careful preparation carried out invisibly over weeks, months, or even years. This sudden emergence is why mushrooms have often been linked to magic in human stories. But in truth, it is efficiency rather than enchantment. A quiet reminder that much of nature's work happens out of sight, waiting patiently for the right moment to reveal itself. Mushrooms have also colored human history in unexpected ways. Long before synthetic pigments existed, people discovered that fungi could be used to dye cloth. Certain species produce rich yellows, warm oranges, deep purples, soft greens, and muted blues. When boiled with wool or silk, these mushrooms release pigments that bind naturally to fibers. The results are subtle, earthy colors that shift gently with light and age. For centuries, wearing mushroom dyed fabric meant carrying a piece of the forest with you, a garment colored not by factories, but by organisms grown from soil and rain. Even today, artisans continue this tradition, valuing fungi not only as food or medicine, but as quiet artists. Painters working in pigments hidden beneath the ground, leaving their mark on cloth rather than canvas. Not all fungi live peacefully on decaying matter. Some species are hunters. In the soil beneath your feet, certain fungi have evolved remarkable ways to capture nematodes, tiny worms that move invisibly through the earth. These fungi build microscopic traps, sticky webs, delicate rings, and looped structures that tighten instantly when touched. Once caught, the worm is pierced and its nutrients absorbed. It is strange to imagine a fungus as a predator, yet these organisms hunt without eyes, speed, or movement. Their weapons are patience and structure. Entire unseen dramas unfold beneath the surface, where fungi and worms interact in silent cycles of survival. Each capture fuels the slow expansion of the fungal network, feeding a kingdom that grows without sound or spectacle. Despite their fragile appearance, mushrooms can be astonishingly strong. The fine threads of mycelium weave together into dense interlocking networks that distribute force efficiently. When studied by material scientists, some mycelium based structures have proven to be stronger than steel when compared by weight. At the same time, they are lightweight, renewable, and biodegradable. Because of this, fungi are being explored as building materials for the future. Mycelium can be grown into bricks, insulation panels, furniture, and even biodegradable packaging. Instead of extracting resources from the earth, these materials are cultivated, shaped by living systems that require little energy and leave no lasting waste. In this way, mushrooms are not only ancient organisms, but possible architects of a more sustainable world. What appears soft and fleeting on the forest floor may in fact hold the strength to reshape how we build live and coexist with the planet. quiet strength grown slowly, thread by thread, beneath our notice. Today, designers and engineers are beginning to look at mushrooms with new eyes. Across the world, experiments are underway to grow building materials from fungi, bricks formed from mycelium, insulation panels grown instead of manufactured, even furniture shaped by living networks rather than carved from trees. These mushroom based materials are strong naturally, fire resistant, and when their use is finished, they can return gently to the earth, fully compostable. There is something quietly astonishing in this idea that a fragile looking mushroom on the forest floor can inspire structures sturdy enough to support human homes. Fungi teach us that resilience does not always announce itself with force or size. Sometimes it is built slowly, invisibly, thread by thread, until strength emerges where we least expect it. Long before forests shaded the land or flowers opened toward the sun, fungi were already here. Fossil evidence suggests that fungi were among the very first organisms to colonize land more than 1 billion years ago. At a time when Earth's surface was mostly bare rock, fungi began breaking stone down into soil, releasing minerals and nutrients. In doing so, they prepared the way for plants to take root. Some scientists believe that hundreds of millions of years ago, enormous fungal structures rose from this early landscape. Towering forms, known as prototaxites, some reaching more than 20 feet tall. These strange organisms may have been the tallest living things of their era, standing alone in a world without trees. Imagine an alien horizon dotted with massive fungal pillars rising silently from the ground long before forests existed. Without fungi paving the way, transforming rock into living soil, the green world we know today might never have formed. They were the quiet pioneers of life on land, shaping the planet, not with speed, but with patience. Not all mushrooms announce themselves with size. Some are so small they can rest on the head of a pin. In the hidden micro world, beneath fallen leaves and rotting wood, tiny mushrooms sprout like grains of dust. Often visible only with magnification, these miniature fungi still perform the same essential work as their larger relatives, breaking down organic matter and releasing spores into the air. Their caps may be no larger than sugar crystals, yet their structures are intricate and delicate, almost jewel-like. Knowing that entire forests of microscopic mushrooms exist all around us unnoticed invites a kind of humility. The forest is not only home to towering trees and large fungi, but also to countless tiny worlds thriving beyond the limits of our sight. At the other extreme, some mushrooms grow to astonishing proportions. The giant puffball mushroom can swell to the size of a beach ball, sometimes weighing more than 20 pounds. When mature, a single puffball releases trillions of spores in a soft, smoky cloud that drifts into the air at the slightest touch. In tropical forests, massive bracket fungi cling to tree trunks like shelves, some broad enough to sit upon. These forms appear less like plants and more like ancient creatures fused to wood and time. In folklore, such mushrooms inspired awe and caution, blurring the line between living organism and myth. From nearly invisible specks to sprawling giants, fungi occupy an extraordinary range of forms. a kingdom of extremes stretching quietly across every scale of life. Some mushrooms communicate through scent, so powerful it can command behavior. Truffles, the prized underground fungi, release aromas so intense that they captivate animals and humans alike. Their scent contains compounds similar to pheromones chemical signals used in communication. For pigs, the attraction is overwhelming. Historically, farmers relied on pigs to locate truffles buried beneath the soil, though the pigs often ate the treasure before it could be harvested. Today, trained dogs are preferred. They can follow the scent without giving in to it. Humans, too, are drawn in. Truffles are among the most expensive foods on earth, valued not for their appearance, but for a rich, earthy fragrance that lingers long after the meal. This scent serves a purpose. By attracting animals that dig them up, truffles ensure their spores are spread farther through the landscape. What feels like luxury and indulgence is also a carefully evolved strategy, a conversation written in chemistry between fungus and world. This subtle strategy has allowed truffles to thrive in darkness because they grow buried underground. Truffles cannot release their spores into the open air like most mushrooms. Instead, they evolved a different solution. They created a scent so rich, so irresistible, that animals are drawn to them from afar. When these animals dig, bite, and carry the truffles away, the spores are spread through soil and forest. What feels like indulgence is actually survival, a quiet agreement between fungus and animal, written not in sound or sight, but in aroma. Deep within forests, trees are not as solitary as they appear. Beneath the surface, they are connected by vast fungal networks that allow them to exchange resources and information. Specialized fungi, known as mycorrhizal fungi, form intimate partnerships with tree roots extending thin mycelial threads far into the soil. Through these living bridges, trees can share sugars, water, and nutrients. If one tree stands in shade, its neighbors in sunlight may send it energy through the fungal web. If insects attack, chemical warning signals can travel underground, giving nearby trees time to strengthen their defenses. This hidden exchange has been called the Wood Wide Web, an underground communication system that turns forests into cooperative communities rather than isolated individuals. Without fungi acting as intermediaries, many seedlings would fail to survive. Forests would be quieter, weaker, and far less resilient. As you walk among trees, it is worth remembering that beneath each step lies a living network translating signals between towering organisms that cannot speak yet communicate constantly. The Wood Wide Web does not stop with individual trees. Entire forests can be linked through shared fungal networks. A single mycelial system may connect dozens or even hundreds of trees, binding them into a single living system. Older mother trees have been shown to pass nutrients to younger saplings through these connections, quietly supporting the next generation. Even dying trees may contribute, releasing their remaining resources into the network where they are redistributed to others. In this way, death becomes nourishment and endings become beginnings. What we see above ground, branches, leaves, trunks, is only the visible half of the forest's life. Below the fungal kingdom, weaves an invisible structure as intricate as a brain's neural web, sustaining balance, memory, and continuity. Mushrooms also play a role in shaping Earth's climate. Fungi help store vast amounts of carbon underground, sometimes for centuries. When plants pull carbon dioxide from the air through photosynthesis, much of that carbon is eventually transferred into the soil through roots and fungal partnerships. Mycelium binds carbon rich compounds into stable forms, slowing their return to the atmosphere. This process turns forests and soils into long term carbon reservoirs, quietly regulating the planet's climate. Without fungi, much of this carbon would escape back into the air far more quickly. In this way, mushrooms act as unseen guardians of atmospheric balance, working patiently beneath our feet while the world above changes. As you rest and listen, it can be calming to imagine this hidden world continuing its work. Threads stretching through soil, messages passing silently between trees, carbon settling gently into the earth, life supporting life in ways that require no attention, no effort, no awareness at all. And perhaps that is part of the lesson fungi offer us, that the most important work is often invisible, that connection does not need noise, and that even in darkness, quiet systems are holding the world together. For us, fungi are quiet reminders that many solutions to human problems already exist in nature, patiently waiting to be noticed. The next time you see a mushroom pushing its way out of a fallen log, you might imagine it as a living laboratory. Inside its tissues, complex chemistry is unfolding, producing compounds not only for its own survival, but sometimes for the healing of organisms far beyond the forest floor. Long before humans built laboratories, fungi were already experimenting, refining, and perfecting chemical strategies over millions of years. Without fungi, bread and beer would not exist. The simple pleasure of bread rising in the oven or beer foaming in a glass depends entirely on fungi. Yeast, a single celled member of the fungal kingdom, feeds on sugars and transforms them into carbon dioxide and alcohol. The gas makes dough swell and soften. The alcohol gives wine and beer their familiar warmth. Archaeological evidence shows that humans were fermenting food and drink thousands of years ago. Long before written language, people had already formed a partnership with fungi. This collaboration shaped daily life rituals, celebrations, and even economies. Entire cultures grew around fermented foods and drinks, all guided by the invisible labor of yeast. In this way, fungi have shaped civilization just as surely as they have shaped forests. Every loaf of bread and every glass of wine carries a legacy of cooperation between humans and the fungal world, a relationship so ancient that it now feels natural and effortless. The yeast used in baking is alive. It's easy to forget that the yeast mixed into dough or poured into a brewing vessel is a living organism. These microscopic fungi consume sugars, reproduce rapidly, and release gases as part of their life cycle. What feels like a simple recipe is in reality a carefully balanced ecosystem. Early humans likely discovered yeast by chance when wild fungal cells drifting through the air settled onto crushed fruit or damp grains. Fermentation began on its own quietly and unexpectedly. Over generations, people learned to guide this process, cultivating specific strains and passing them down like living tools. Today's yeast may be refined and selected, but it remains part of the same fungal lineage as the mushrooms growing in forests. Billions of cells working together, unseen and uncelebrated, transform sweetness into nourishment. In every bite of bread, there is a hidden story of cooperation between life forms separated by scale, but united by chemistry. Some mushrooms appear to bleed. In certain damp forests, you might encounter a mushroom that seems almost alive in an unsettling way. Bright red droplets bead on its surface, giving the impression that it has been wounded. One of the most striking examples is the so-called bleeding tooth fungus. The crimson liquid is not blood, but a fluid rich in pigments and chemical compounds. Scientists are still exploring its purpose. It may help regulate moisture, discourage insects, or protect the fungus from microbial competitors. Whatever its function, the effect is deeply uncanny. To stumble upon such a mushroom feels like witnessing nature borrowing familiar symbols for unfamiliar purposes. The forest is not performing for us. These forms exist entirely for the needs of the organism itself. We are only passing observers, catching brief glimpses of systems that operate without concern for human meaning. In moments like these, mushrooms remind us that the natural world is not designed to comfort or frighten us. It simply exists, following rules older than memory. And sometimes those rules produce sights so strange and beautiful that they linger in the mind long after we've walked away. Not all mushrooms survive by being beautiful. Some survive by smelling terrible. Certain fungi release odors so intense they resemble rotting flesh. These are known as stinkhorns, and their scent is almost indistinguishable from decaying meat. To humans, the smell can be shocking, even nauseating. But to flies and beetles, it is irresistible. This is no accident. The odor draws insects in, luring them to land on the mushroom's surface. As they walk across it, spores cling to their legs and bodies. When the insects fly away, they unknowingly carry the mushroom's offspring with them. Repulsion becomes a tool. Disgust becomes a delivery system. Across history, stinkhorns have unsettled people. Their sudden appearance and foul smell gave rise to myths, omens, and stories of spirits lurking in the soil. But stripped of superstition, the truth is simpler and more elegant. These mushrooms are not warning of death. They are performing a survival strategy perfected over millions of years. In a quiet forest, the scent of decay may not mean something has ended. It may mean something has just begun. Fungi also build vast underground structures that rival human cities. When mycelium spreads through the soil, it does not grow at random. It organizes itself into complex layered networks. Threads branch, reconnect, and reinforce one another, forming efficient pathways for water, nutrients, and chemical signals. Some regions function like highways, moving resources quickly across long distances. Other areas act as storage zones, holding reserves until conditions change. There are even exchange hubs where fungi trade nutrients with plant roots, balancing supply and demand across the network. Advanced imaging has revealed that these systems optimize themselves, adjusting routes and strengthening connections much like engineered infrastructure. Without blueprints or planners, fungi construct hidden architectures of remarkable efficiency. Above ground, we build roads and towers. Below ground, fungi weave living cities, silent, adaptive, and alive. The soil beneath your feet is not empty. It is crowded with cooperation. Some mushrooms reveal their chemistry when touched. In the fungal kingdom, surfaces can be deceptive. Certain mushrooms change color when bruised, sliced, or simply handled. One well known example is the blue staining bolete, which turns a deep cobalt blue almost instantly when exposed to air. This dramatic transformation happens through chemical reactions between compounds in the mushroom and oxygen. For foragers, the color shift can be an important clue for identification. For observers, it feels almost magical. A plain looking mushroom suddenly transforms as if revealing a hidden identity beneath its skin. In earlier times, such changes were seen as signs of enchantment. Mushrooms that altered their appearance were believed to carry secret powers. Today, we know the cause is chemistry, but the sense of wonder remains. With a single touch, the forest performs a quiet trick, reminding us how easily science can feel like sorcery when we witness it firsthand. Not all mushroom scents repel. Some are surprisingly sweet. While certain fungi smell of decay, others release aromas that seem crafted for human delight. One remarkable example is the candy cap mushroom. Its scent closely resembles maple syrup, and when dried, the fragrance becomes even stronger. The aroma comes from specific chemical compounds that trigger our brain's associations with sweetness. Chefs use these mushrooms to flavor desserts, baked goods, and ice creams, turning a forest discovery into something that feels almost magical. To encounter one in the wild is unexpected. Amid damp leaves and moss, the air suddenly carries the warmth of sugar and breakfast kitchens. It feels like stumbling on what a hidden pantry beneath the trees. Mushrooms remind us that the forest is not only a place of decay and shadow, it is also a place of fragrance, flavor, and surprise. A world where sweetness and rot exist side by side, each serving life in its own way. It's a quiet reminder that fungi are master chemists. They compose with molecules the way musicians compose with sound. Some scents are designed to repel, others to attract, and some exist simply to surprise. From the sharp odor of decay to the sweetness of maple syrup, mushrooms create an invisible symphony of smells, each note written in chemistry we are only beginning to understand. And the range is astonishing. Some mushrooms smell like coconut or almonds. Just as flowers carry diverse fragrances, fungi release aromas that echo familiar foods. Certain species give off a soft coconut scent. Others smell unmistakably of almonds or marzipan. The almond-scented agaricus, for example, carries a fragrance so close to the nut that foragers sometimes use scent as a key clue for identification. Coconut-scented russulas, meanwhile, seem to bring tropical warmth into cool forest air. These aromas come from volatile compounds that drift easily into the air. Sometimes they attract animals. Sometimes they deter predators, and sometimes they serve no obvious purpose to us at all. To humans, they become moments of wonder, proof that the chemistry of fungi overlaps with kitchens, memories, and comfort. To lean close to a mushroom and catch the scent of dessert or fruit is a strange experience. For a brief moment, the forest feels less wild and more familiar, as though it is quietly dreaming of flavors we know, weaving sweetness into its hidden growth. Mushrooms are also remarkable sources of vitamin D. Few foods naturally contain this essential nutrient. But mushrooms have a rare ability. Like humans, they can produce vitamin D when exposed to sunlight. When ultraviolet rays touch the surface of a mushroom, compounds within it transform into vitamin D. For us, this vitamin supports bone strength, immune function, and emotional balance. A small serving of sun exposed mushrooms can contain as much vitamin D as a supplement. In some cultures, freshly harvested mushrooms are intentionally placed in sunlight before cooking, allowing them to increase their nutritional value naturally. It is striking to realize that mushrooms and humans share this relationship with light. Though fungi grow in shaded forests and dark soil, a moment in the sun allows them to store its energy. In this way, mushrooms become a quiet bridge between sunlight and the underground world, between sky and soil, between energy and nourishment. In some mushrooms, even poison can glow. There are fungi where danger and beauty intertwine. Certain toxic species are also bioluminescent, emitting a soft green or blue light in the darkness. This glow is produced through chemical reactions involving luciferin and enzymes that release light without heat. The purpose of this glow is still debated. It may attract insects to help spread spores. It may deter animals, or it may simply be a byproduct of complex chemistry that evolved for survival. Whatever its function, the result is haunting. To encounter a glowing mushroom at night is to see living light rising from decay, a reminder that in nature even toxins can shine. Even danger can be beautiful, and even in the darkest corners of the forest, chemistry quietly turns death into illumination. Scientists believe this glow may serve more than one purpose. It might discourage animals from eating the mushroom. It may attract insects that help carry spores through the night. Or it could act as a subtle signal within the living web of the forest itself. Whatever its role, the light is most striking after sunset, when the ground appears to shimmer as if the forest floor is quietly breathing with a pale, otherworldly radiance. To encounter glowing mushrooms in the dark can feel both beautiful and unsettling. Organisms that are toxic to touch, yet softly illuminated from within, standing like quiet warnings among leaves and fallen wood. For centuries, such sights fed human imagination. In folklore, bioluminescent fungi were often seen as signs of spirits' omens or gateways between worlds. Their ghostly light suggested that something unseen was present, watching from the shadows. Modern science can explain the chemistry behind the glow, but explanation does not erase wonder. There is still something deeply arresting about life, transforming danger into light, defense into radiance, decay into illumination. Among the most feared fungi on Earth is the death cap mushroom Amanita phalloides. It does not look threatening. A pale greenish cap, a white stem, a form that could easily be mistaken for an edible species. But inside it carries amatoxins, among the most lethal natural poisons known. As little as half a cap can be fatal to an adult. What makes the death cap especially cruel is its delay. Symptoms often do not appear for many hours. Victims may feel fine at first, believing the danger has passed, while inside the body, the liver and kidneys are already being destroyed. By the time illness becomes severe, the damage may be irreversible. There is no true antidote. Doctors can provide supportive care, and in some cases, a liver transplant is the only hope. Even then, survival is uncertain. Throughout history, this single mushroom has caused countless accidental deaths. Its existence is a quiet reminder that nature does not advertise its dangers. In the forest, beauty and lethality often share the same fragile form. Yet fungi are not only agents of harm. At times, they have been unexpected saviors. In the 19th century, cholera was one of the most feared diseases on Earth. It swept through cities and villages, killing millions across Europe, Asia, and beyond. At a time when medicine offered few effective treatments, researchers noticed something remarkable. Certain fungi could halt the growth of the cholera bacterium. One such fungus, Penicillium glaucum, a relative of the mold that would later give us penicillin, showed the ability to suppress the disease. Scientists did not yet fully understand why it worked, but its effects were undeniable. This discovery offered some of the earliest evidence that fungi produced substances capable of fighting deadly infections. Long before antibiotics were formally discovered, the fungal kingdom was already waging chemical wars against bacteria, quietly, invisibly crafting compounds that would one day help save millions of human lives. In this way, mushrooms embody one of nature's deepest contradictions. They can be lethal or life-saving, silent destroyers or quiet healers. Their power lies not in intention, but in chemistry. And beneath the forest canopy, that chemistry continues its work, indifferent to fear, hope, or history, shaping life in ways we are still only beginning to understand. In time, the wider discovery of antibiotics confirmed what this humble fungus had been quietly suggesting all along. Fungi carry chemical tools powerful enough to alter the course of human history. Entire cities once lived in fear of invisible enemies, only to find relief in the soft bloom of mold growing unnoticed on food or stone. That early moment was a whisper of the antibiotic revolution yet to come, a reminder that salvation does not always arrive with fanfare. Sometimes it emerges silently from the smallest and most overlooked forms of life. Mushrooms and their relatives have stood again and again between humanity and its deadliest threats. Fungi can remember past conditions. It may sound unlikely, but research suggests that fungal networks possess a kind of memory. In laboratory studies, mycelial systems exposed to changes in temperature, moisture, or nutrients responded more efficiently when those same conditions returned later. The network adjusted faster the second time, as if it had learned from experience. This is not memory, in the way humans remember stories or faces. Instead, it is biological memory encoded in structure and behavior. The threads themselves change subtly, reshaping how resources flow and how growth unfolds. This quiet form of recall may help explain why fungi are among the most adaptable organisms on Earth. They do not simply react, they remember patterns and adjust accordingly. To walk through a forest is to move across a living archive. Beneath the soil, fungal networks carry traces of past droughts, floods, fires, and seasons. The land remembers through them. The earth itself holds memory woven into threads too fine for our eyes to see. Some mushrooms can survive being frozen solid. When winter seals the ground in ice, it seems natural to assume mushrooms would disappear. Yet some species endure the cold with remarkable resilience. Certain fungi can freeze completely their cells locked in ice, only to revive when warmth returns. Others continue to grow beneath snow, slowly pushing their caps upward through frost as if winter were merely a pause, not an ending. Their survival depends on antifreeze like compounds that protect delicate cells from damage. For organisms that appear so soft and fragile, this endurance is astonishing. It allows fungi to colonize tundra alpine regions and polar landscapes where few plants can survive. To discover a mushroom emerging through snow is to witness quiet defiance, life persisting where stillness seems absolute. Even in the harshest cold, unseen kingdoms continue their slow labor, decomposing, recycling, preparing the way for renewal. Winter does not stop them, it only slows their breath. Mushrooms have been used in traditional medicine for thousands of years. Across cultures and continents, fungi have long been regarded as healers. In traditional Chinese medicine, reishi mushrooms are known as the mushroom of immortality, believed to support longevity, resilience, and balance within the body. Ancient texts describe their use in restoring energy, calming the spirit, and strengthening the body's defenses. These traditions emerged long before modern science could isolate compounds or measure immune responses. Yet today, researchers are discovering that many medicinal mushrooms contain substances that influence inflammation, immunity, and cellular health. Once again, ancient knowledge and modern science quietly meet in the forest. Long before laboratories and hospitals, people turned to mushrooms not only for food, but for healing. They listened to the land, and the land through fungi answered. In Japan, shiitake mushrooms were once considered so valuable that they were reserved for nobility, used as a tonic to support strength and vitality. Across the world, indigenous cultures in Siberia, North America, and Africa developed their own mushroom medicines. They brewed fungal teas, prepared poultices, and applied mushroom extracts to wounds, fevers, and exhaustion. Long before microscopes existed, people learned through careful observation that fungi could heal. Today, modern science is beginning to confirm what ancient healers sensed through experience. Researchers have identified compounds in many mushrooms that support the immune system, reduce inflammation, and even show potential anti-cancer effects. When you drink mushroom tea or hear about medicinal extracts, you are participating in a tradition that stretches back thousands of years. a quiet partnership between humans and fungi shaped by survival curiosity and reverence for the natural world. Lion's mane mushroom offers one of the most intriguing examples of this healing potential. With its soft, cascading spines that resemble frozen icicles, lion's mane is both striking and gentle in appearance. Studies in animals have shown that compounds inside this mushroom can stimulate the growth of nerve cells. These molecules encourage the production of nerve growth factor, a substance essential for maintaining and repairing neurons. Because of this, lion's mane has attracted growing interest as a possible aid in conditions such as Alzheimer's and Parkinson's disease. For centuries, it was used in traditional Asian medicine as a tonic for the mind. Now, science is beginning to explain why. It is astonishing to imagine that a mushroom growing quietly on a fallen log might carry within it the ability to support the brain's most delicate networks. Once again, the forest hints that answers to complex human problems may lie hidden in plain sight. Some mushrooms disperse their future in dramatic bursts. Puffball mushrooms, when mature, fill their rounded bodies with millions upon millions of spores. At just the right moment, a raindrop, a passing animal, or a gentle touch causes the mushroom to release a sudden cloud into the air. What looks like smoke is actually life itself spreading outward, each spore a tiny vessel of possibility. For children and wanderers, puffballs often inspire delight, like a small firework blooming at ground level. But beyond the wonder is remarkable efficiency. In a single release, vast numbers of spores can be carried away by the wind, ensuring that the species continues. To witness a puffball erupt is to see persistence disguised as play, a fleeting moment where survival takes on the form of drifting mist. Fungi are also the silent workers behind every forest floor. When autumn covers the ground with fallen leaves, fungi begin their essential task. Without them, forests would slowly suffocate beneath their own debris. Fungal enzymes break down cellulose and lignin, the tough materials that give leaves and wood their strength. What appears to be decay is in truth a sophisticated recycling system. As leaves dissolve into soil, the nutrients they hold are released, feeding the next generation of plants. Every spring bloom, every blade of grass depends in part on this hidden process. Fungi ensure that nothing is wasted. They turn endings into beginnings, death into nourishment, stillness into growth. To walk through an autumn forest is to move across an invisible economy powered by mushrooms. Beneath each step, fallen leaves are being transformed quietly and continuously into the foundation of future life. Without fungi, the world would drown in its own remains. With them, the cycle of renewal never truly stops. Each year, an unimaginable amount of life returns to the ground. Leaves fall by the billions. Branches crack and collapse. Entire trees come down. Animals live, die, and fade back into the soil. Without fungi, all of this organic matter would accumulate endlessly, stacking layer upon layer until the surface of the earth was buried beneath its own history. Fungi prevent that fate. They are nature's master recyclers, releasing powerful enzymes capable of breaking apart the toughest substances in existence. Wood leaves cartilage, even bone, are slowly dismantled and transformed. What once seemed solid and final becomes soil nutrients and breathable air ready to support new life. If fungi were suddenly removed from the planet, forests would suffocate beneath their own remains. The cycles that allow life to renew itself would stall, then stop. Every step you take on a forest floor is possible only because countless fungal threads have already done their work, dissolving yesterday's endings into tomorrow's beginnings. They do this without sound, without speed, and without recognition. In patience and persistence, fungi keep the earth breathable, livable, and endlessly renewing. They are the unseen caretakers, quietly preventing the world from drowning in its past. Some mushrooms remain almost invisible until night arrives. In daylight, they blend seamlessly into bark soil and fallen leaves, hiding in plain sight. But when darkness settles, they reveal a secret. Certain fungi begin to glow, casting soft light in shades of green blue or pale yellow. To encounter one in a nighttime forest can feel unreal, as though the ground itself has learned to shine. These bioluminescent mushrooms create their light through a delicate chemical reaction within their cells, similar to the process that makes fireflies glow. Some species shine only after sunset, conserving their energy during the day as if their performance is meant solely for the darkness. For centuries, such glowing fungi fueled stories of spirits, fairies, and wandering lights meant to guide or mislead travelers beneath the moon. Even now, their presence feels otherworldly, proof that the forest carries its own quiet lanterns, waiting patiently for the stars before they turn on. Fungi are also capable of forming one of nature's most remarkable partnerships: lichens. The colorful crusts and branching shapes found on rocks, trees, and ancient stone are not single organisms at all. They are living collaborations. In this partnership, a fungus provides structure, shelter, and moisture, creating a safe environment. Within that shelter lives algae or cyanobacteria, which use sunlight to produce food through photosynthesis. Together, they form a new life system stronger than either partner could be alone. This alliance allows lichens to survive in some of the harshest environments on Earth: frozen tundra, bare cliffs, scorching deserts, even the vacuum like conditions of outer space, where almost nothing else can endure. These fungal partnerships persist, growing slowly, patiently, molecule by molecule. Lichens remind us that survival is not always about strength or speed. Sometimes it is about cooperation, about learning how to share resources, protect one another, and adapt together to a difficult world. In the quiet places where life seems impossible, fungi are often already there, building alliances, rewriting the rules of survival, and proving once again that the hidden kingdom beneath our notice is one of the most powerful forces shaping life on Earth. Lichens are among the oldest and most resilient pioneers on Earth. They are often the first being to settle on bare stone, patiently breaking it down grain by grain, preparing lifeless rock to one day become soil. In doing so, they paint the world with soft patches of green, yellow, and orange, subtle signatures of life's quiet persistence. At their core, lichens reveal something profound. Fungi are not merely scavengers feeding on decay. They are also farmers, carefully cultivating their partners in one of nature's earliest and most successful collaborations. Each lichen is a living agreement between kingdoms, a reminder that survival does not always belong to the strongest competitor, but often to those willing to cooperate. Not all mushrooms reveal their value immediately. Some are edible only after they are cooked. Even species that are not truly poisonous can contain compounds that irritate the body or resist digestion when raw. Heat changes everything. Morels celebrated in kitchens around the world are a perfect example. Uncooked, they can cause discomfort, but once sauteed or roasted, they become rich, nutty, and deeply satisfying. Shiitake mushrooms behave in a similar way, releasing deeper aromas and unlocking nutrients only when warmth activates their chemistry. It is as if fire completes their transformation. What begins as something uncertain becomes nourishing through patience and care. For foragers, this knowledge has been passed down across generations. Cooking becomes a kind of quiet ritual, turning risk into reward. Mushrooms remind us that food is not always simple. Sometimes it asks for understanding, respect, and time before it offers its gifts. Other mushrooms make no attempt to be inviting at all. Some defend themselves not with poison, but with bitterness so intense it overwhelms the senses. The bitter bolete, for example, closely resembles edible relatives, yet delivers a flavor so harsh that a single bite can spoil an entire meal. This bitterness acts as a warning, a clear message to predators to leave it alone. For humans, bitter taste has long served as an internal alarm system, urging caution. In the fungal world, flavor itself becomes a tool of survival. Yet even these unpalatable mushrooms play their part, breaking down organic matter and enriching the soil. They remind us that not everything in the forest exists for human use. Taste becomes part of a larger dialogue between species, shaping who consumes and who is spared. Some fungi go even further, producing compounds that profoundly alter the human mind. Among the most well known are mushrooms containing psilocybin, a molecule capable of reshaping perception itself. Time may stretch or dissolve, colors intensify. The boundary between self and world can feel thinner, more fluid. For thousands of years, such mushrooms were used in ceremonial and spiritual contexts, believed to open pathways to insight, healing, or the sacred. In recent decades, science has returned to these fungi with fresh curiosity. Researchers are exploring their potential to ease depression, anxiety, and addiction, discovering that these ancient organisms may offer new approaches to mental health. That a small mushroom can so deeply influence consciousness is remarkable. It suggests that fungi do more than recycle forests. They can also reshape awareness. Whether regarded as sacred, dangerous, or therapeutic, these mushrooms exist at the meeting point of biology and mystery, carrying the power to change how reality itself is experienced. Hints of this relationship may stretch far into our past. In caves across Spain and parts of North Africa, prehistoric paintings depict human figures holding shapes that resemble mushrooms. Some scholars believe these images suggest early humans not only gathered fungi for nourishment, but also for altered states of mind. If true, it would mean that humanity's bond with mushrooms reaches back to the dawn of symbolic thought itself. Long before written language, fungi may already have been companions in exploration, guiding early humans through experiences that felt larger than the physical world alone. The images show dancing figures, bursts of color, and repeating patterns that closely resemble the kinds of visions reported during altered states caused by hallucinogenic mushrooms. While certainty is impossible, the idea that humans may have explored fungal induced states of consciousness tens of thousands of years ago is deeply compelling. It suggests that mushrooms were influencing ritual culture and imagination from the very beginning of symbolic expression. To picture early humans gathered around firelight, painting mushrooms onto cave walls as markers of journeys beyond ordinary awareness is to sense a continuity across millennia. Fungi may have shaped not only survival, but storytelling itself, guiding how humans understood the unseen world long before written history began. Today, fungi are once again offering solutions for the future. In a world overwhelmed by plastic waste, mushrooms may help redefine how we package and protect objects. Mycelium can be grown inside molds, forming lightweight yet sturdy materials that resemble polystyrene foam. Unlike synthetic packaging, these mycelium based materials are fully biodegradable. Companies are already replacing styrofoam in shipping, electronics, and furniture packaging with mushroom grown alternatives. After use, the material can be composted, returning harmlessly to the soil. The process relies on agricultural waste to feed the mycelium, making it both renewable and efficient. It is remarkable to realize that the same organism fruiting quietly in forests could one day cushion fragile goods, leaving behind no long term pollution. Where plastic lingers for centuries, fungi complete a cycle of growth, use, and return. Some forms of mycelium also possess another unexpected property. They naturally resist fire. When grown into building materials, certain mycelium composites do not ignite easily. Instead of bursting into flame or releasing toxic smoke, they char slowly and remain structurally stable. This makes them promising candidates for insulation furniture and architectural use. The resistance comes from chitin and complex sugars within fungal cell walls, which naturally slow combustion. Researchers now imagine walls and structures reinforced with fungal networks, providing safety without chemical fire retardants. The same threads that bind forest soil together may one day help protect homes from fire, quietly offering resilience shaped by evolution rather than industry. Fungi are also redefining materials we associate with fashion and design. Traditional leather, though durable, requires extensive resources and animal agriculture. Mycelium based leather alternatives offer another path. Grown in controlled environments, fungal leather can be shaped into sheets, treated, and finished to resemble animal hide. This material is breathable, flexible, and biodegradable. Designers are already producing footwear bags and furniture using mycelium leather. Unlike animal hides, which take years to produce fungal leather, can be grown in weeks using minimal water and no animals. Its texture can be tuned from soft and suede like to smooth and firm. The idea that a mushroom network could become clothing or furniture highlights fungi not just as recyclers or healers, but as inventors offering ethical and sustainable alternatives. In colder environments, fungi reveal yet another adaptation. Some species produce natural antifreeze compounds that protect their cells during freezing temperatures. These proteins and sugars lower the freezing point of water inside fungal tissues, preventing, preventing ice crystals from forming and damaging cells. This allows fungi to remain active even in winter, continuing to decompose organic matter while much of life slows down. In some cases, these antifreeze compounds affect the surrounding microenvironment, softening frost near the fungus itself. Scientists are studying these molecules as models for protecting crops from frost or developing safer de-icing methods. It is striking that such complex solutions emerge from organisms small enough to fit in the palm of your hand. Fungi are also master extractors of minerals. Without tools or movement, they slowly dissolve stone by releasing organic acids. Over time, these acids free essential nutrients such as calcium, magnesium, and potassium from rock. This process transforms barren stone into fertile soil, laying the groundwork for ecosystems to form. Long before plants could take root, fungi were already preparing the land. Even today, this silent mining continues beneath forests and fields, turning geology into biology. Through patience measured in centuries, fungi convert the solid bones of the earth into living ground. This quiet process may have begun more than 1 billion years ago, when fungi were among the very first pioneers to cross Earth's bare rocky landscapes. Long before soils existed, before roots could grip the ground, fungi slowly spread across stone, preparing the land for life to follow. Even today, lichens' ancient partnerships between fungi and algae continue this work. They cling to cliffs, boulders, and gravestones, carving away at rock grain by grain. Though tiny and easily overlooked, their persistence reshapes entire mountainsides over immense spans of time. Inspired by this natural patience, scientists now imagine biomining technologies modeled after fungi, extracting rare minerals gently without the scars left by heavy machinery. To stand before a rocky outcrop and realize it is being quietly transformed, molecule by molecule, by unseen fungal threads, is to witness patience turned into power. In places where human life struggles, mushrooms sometimes flourish. At sites like Chernobyl, fungi have been found growing amid rubble saturated with radiation. These species contain melanin, the same pigment found in human skin, but here it appears to serve a remarkable additional function. Instead of merely protecting cells, the melanin seems to help convert radiation into usable energy, a process researchers call radiosynthesis. It is as if these mushrooms perform a form of photosynthesis using radiation instead of sunlight. This discovery opens astonishing possibilities. Fungi that could help clean radioactive waste. Fungi that might shield astronauts on deep space journeys. In landscapes shaped by catastrophe, Mushrooms demonstrate that life can adapt even to the most hostile conditions, transforming what we call poison into fuel. Where survival seems impossible, fungi quietly find a way. Mushrooms may also have played a decisive role in one of the greatest transitions in Earth's history. When the first plants ventured out of the oceans onto land, they encountered a harsh environment. Bare rock, scarce nutrients, and no established soil. Fossil evidence suggests they were not alone. Fungi were already present, forming early partnerships with these pioneering plants. Through these alliances, fungi helped extract minerals from stone and shared them with plants receiving sugars in return. Together, they built the first thin layers of soil. Over millions of years, this cooperation made forests, grasslands, and entire ecosystems possible. Without fungi, plants may never have taken hold on land, and Earth might still be a barren world of stone. Every tree, every field, every blade of grass carries the imprint of this ancient collaboration. When you walk across the ground today, you walk on terrain prepared by fungi long before humans ever appeared. Fungi are not confined to forests and soil. They also live beneath the waves. Marine fungi have been discovered forming relationships with coral reefs, weaving themselves into these delicate underwater structures. Though still poorly understood, these partnerships may help regulate nutrients, protect corals from disease, or stabilize reef ecosystems under increasing stress. As oceans warm and reefs face unprecedented challenges, marine fungi may prove to be quiet allies in coral survival. To imagine fungal threads drifting among coral polyps is to realize that the fungal kingdom extends far beyond land. It reaches into saltwater stitching together life in places we rarely consider. If corals are the architects of reefs, fungi may be their unseen caretakers, sustaining balance beneath the surface. Mushrooms are also remarkable in how they reproduce. Fungi can spread asexually, releasing vast numbers of spores that are genetically identical, allowing rapid colonization across soil, wood, and air. This method is efficient, fast, and expansive. At the same time, fungi are capable of sexual reproduction, exchanging genetic material to create diversity. This dual strategy gives fungi extraordinary flexibility. They can spread quickly when conditions are favorable and adapt when environments change. It is one more reason they have survived every major upheaval in Earth's history. Masters of persistence, variation, and balance, fungi quietly ensure that life continues no matter how the world shifts around them. This remarkable flexibility gives fungi the ability to endure shifting climates, new predators, disease, and unfamiliar environments. Some species can even alternate between reproductive strategies depending on conditions, choosing speed when expansion is needed or genetic diversity when survival is at stake. Imagine a life form equipped with two entirely different blueprints for continuation, one designed for rapid spread, the other for long-term resilience. Few organisms on Earth possess such versatility. Each mushroom you encounter may be the result of countless generations of cloning or the product of an intricate genetic exchange. It stands as a quiet reminder that fungi are not limited to a single way of existing. They carry many possibilities within them, at once adapting endlessly without announcing the change. In the fungal world, reproduction reaches levels of diversity that stretch human imagination. Some species possess not two, not dozens, but tens of thousands of mating types. The split gill mushroom, for example, may have more than 23,000. These are not genders as humans define them, but compatibility patterns written into DNA, determining which individuals can successfully combine genetic material. The outcome is extraordinary. Nearly any two individuals can mate, greatly reducing inbreeding and maximizing genetic variation. Where many organisms are constrained by limited reproductive options, fungi turn diversity into an advantage. Evolution, in their case, favors openness rather than restriction. To study a mushroom's mating system is to glimpse life experimenting freely, unconcerned with categories we often assume are universal. For fungi, diversity is not an exception, it is the foundation. When a puffball mushroom matures, it becomes a vessel of abundance. Its interior fills with a fine powder of spores waiting patiently for release. A single raindrop, a falling leaf, or the brush of an animal can trigger an eruption. What appears as a small cloud of dust is in fact a vast biological event. One large puffball can release trillions of spores, more than the total number of humans who have ever existed. Most will never grow, drifting into places too dry, too cold, or too hostile, but a few will find the narrow window of conditions they need, and from them, entire networks will emerge. This strategy relies not on certainty, but on scale, overwhelming chance with sheer numbers. To watch a puffball burst is to see the forest exhale, a brief moment when the invisible becomes visible and possibility scatters into the wind. The reach of fungi does not end at ground level. Spores rise on air currents, lifted far above trees, rooftops, and city streets. Scientists have detected them thousands of feet above urban centers, suspended among dust pollen and microscopic debris. Some are drawn into clouds, later returning to Earth, with rainfall settling on landscapes far from where they began. Every breath taken in a city carries traces of these travelers. Fragments of distant forests, fields, and soils move through the air unnoticed. Even surrounded by concrete and steel, we remain connected to fungal networks that span continents. The atmosphere itself becomes a bridge linking wild ecosystems and human spaces through an unbroken flow of spores. And these drifting particles may influence something even larger. High in the atmosphere, spores can act as nuclei around which water droplets form. In this way, fungi may quietly contribute to cloud formation and rainfall patterns. Tiny, weightless, and unseen, they participate in processes that shape weather systems across the planet. From underground networks to the skies above cities, mushrooms reveal a truth that grows clearer the deeper we look. Life does not operate in isolation. It moves through air, soil, water, and time itself, weaving connections so subtle we rarely notice them. And all around us, fungi continue their work. Silent architects of balance, drifting between worlds, shaping the planet one invisible thread at a time. Around these drifting particles, clouds can begin to take shape. In this quiet way, fungi may help influence when and where rain falls, participating gently in Earth's vast climate rhythms. Forests may not only recycle nutrients below ground, but also reach upward, releasing spores that rise into the sky and encourage moisture to gather. The research is still unfolding, but it suggests that mushrooms influence far more than soil. Their reach may extend into the patterns of the atmosphere itself. Imagine raindrops forming around spores released from a distant forest, carried by wind for days before falling over fields, rivers, and cities far away. In this sense, fungi blur the boundary between earth and sky. Life does not stop at the surface. It flows upward, outward, and everywhere in between, carried on invisible currents. In places damaged by human industry, fungi often emerge as unexpected healers. Certain species can absorb and store heavy metals such as lead, mercury, and cadmium. Their mycelial networks act like living sponges, drawing toxins out of contaminated soil and concentrating them within their fruiting bodies. This process, known as mycoremediation, offers a gentler way to restore polluted land without digging, burning, or harsh chemicals. Though these mushrooms become unsafe to eat, they have already fulfilled their role, transforming poisoned ground back into usable soil. Picture a scarred landscape slowly changing as mushrooms rise, quietly filtering danger from the earth. In their patient work, fungi reveal a powerful lesson. Even in places deeply harmed, recovery can begin through stillness and time. Mushrooms can also help heal oil soaked land and water. When oil spills occur, damage can persist for decades. Yet some fungi are capable of breaking down hydrocarbons, the complex molecules that make up oil, into harmless components. Their mycelium releases enzymes that dismantle toxic sludge, turning dark, lifeless soil into ground where plants can grow again. In experimental sites, areas treated with fungi have transformed within weeks. What was once blackened earth becomes green. Insects return, birds follow. The land begins to breathe again. This approach suggests that mushrooms may one day assist in repairing some of humanity's most severe environmental wounds, not through force, but through quiet biological precision. Beyond their ecological power, mushrooms also continue to surprise the senses. While many are known for earthy, savory flavors, a few rare species carry aromas reminiscent of chocolate or cocoa. These unexpected notes come from aromatic compounds that interact with our senses in familiar ways. To walk through a forest and catch a scent that feels warm and sweet, like a distant bakery, is deeply disorienting and delightful. For chefs and foragers, such mushrooms offer strange possibilities. Desserts flavored not by cacao beans, but by forest fungi. Another reminder that mushrooms defy expectation, reshaping how we think about taste, comfort, and nature's creativity. And in the darkness, some mushrooms reveal one final secret. In tropical forests and damp woodlands, bioluminescent fungi glow with a soft green light, sometimes bright enough to illuminate fallen leaves nearby. The glow is produced by a chemical reaction involving luciferin and luciferase, similar to the light of fireflies. Scientists believe this gentle radiance may help attract insects spreading spores under the cover of night. To encounter such mushrooms in the dark feels unreal, as though the forest itself has placed lanterns on the ground. For centuries, people spoke of foxfire and fairy lights shimmering from rotting logs. Today, we understand the chemistry, but the wonder remains. Living light rising from decay, glowing quietly where few ever look. They remind us that even in darkness, life finds ways to glow. Small green lights rise quietly from the forest floor, carrying the story of survival forward, one gentle shimmer at a time. Long before forests filled the land, mushrooms once stood as giants. Hundreds of millions of years ago, Earth looked nothing like it does today. Before towering pines and spreading oaks, enormous fungi, known as prototaxites, dominated the landscape. These strange life forms grew up to 30 feet tall, making them the tallest organisms of their era. They rose like pillars across ancient plains at a time when insects had only just begun to fly. Fossil evidence suggests these giants resembled massive tree trunks, yet they were neither plants nor trees. They were fungi. Imagine a primeval world dotted with towering fungal spires standing alone against a barren horizon. These ancient organisms helped prepare the land for what would come later, breaking down rock-forming soil and laying the groundwork for future ecosystems. Today's mushrooms may seem small and fleeting, but their ancestors once ruled the land, guardians of a forgotten age, when fungi, not trees, were the giants of Earth. Some fungi can survive without water for years. Water is usually seen as essential for life, yet certain fungi defy this rule. Desert fungi and lichens can dry out completely, losing nearly all moisture until they appear lifeless. Then, when rain finally arrives, they awaken and continue growing as if nothing happened. Their cells are protected by special sugars and proteins that prevent collapse during extreme drought. This remarkable ability allows fungi to live in deserts, rocky cliffs, and other harsh environments where few organisms can endure. Scientists study these fungi to understand how life might survive on Mars or other arid worlds. Imagine a fragile fungal thread lying dormant for years, brittle and still, then springing back to life with the first touch of moisture. Their survival strategy is not resistance, but patience, waiting quietly until conditions return. Because of this resilience, mushrooms have been sent into space. Researchers have carried fungi and spores aboard spacecraft to patent how they respond to microgravity and cosmic radiation. To their surprise, many fungi survived, and some continued to grow. A few even altered their chemistry, adapting to the extreme conditions of space. These experiments suggest fungi could play roles in future space missions, recycling waste, producing food, or helping shield astronauts from radiation. Some scientists even speculate that hardy spores might survive interplanetary journeys, drifting through space to seed new worlds. Whether or not that proves true, mushrooms growing in orbit expand our idea of where life can exist. A fungus thriving beyond Earth hints that this hidden kingdom may have cosmic potential. Back on Earth, fungi quietly protect our crops. Beneath fields of wheat, corn, and rice, invisible fungal partners work alongside plant roots. These mycorrhizal fungi not only help plants absorb nutrients, but also strengthen their defenses. By activating a plant's immune responses and outcompeting harmful microbes, fungi reduce disease and stress. Farmers are beginning to embrace these ancient partnerships, using fungal inoculants to decrease dependence on chemical pesticides. Imagine crops protected not by sprays, but by living networks beneath the soil. Agriculture in this light becomes cooperation rather than conflict. Just as forests rely on fungi, the farms of the future may depend on these same underground allies. Mushrooms have also shaped modern medicine. Beyond antibiotics, fungi produce compounds that save lives every day. Substances derived from fungi help lower cholesterol, suppress immune rejection after organ transplants, and fight cancer. Lovastatin, a drug that transformed heart medicine, originated from fungi. Cyclosporin, essential for transplant surgery, was discovered in a soil-dwelling fungus. Time and again, fungi reveal themselves as quiet chemists, crafting molecules that alter the course of human history. What appears as a simple mushroom in the forest may hold the chemistry that keeps a heart beating or an organ accepted. In their silence, fungi remind us that some of the most powerful forces shaping our lives grow unnoticed beneath our feet. Researchers continue to explore the fungal kingdom, searching for the next breakthrough, hidden in a forest, a meadow, or even a forgotten corner of a laboratory. For centuries, traditional medicine has relied on mushrooms, but modern science is only now beginning to understand how powerful their chemistry truly is. Every cap, every strand of mycelium may contain molecules capable of saving lives. Walking through the woods can be like wandering through a living pharmacy where remedies lie quietly beneath bark and moss waiting to be discovered through patience and curiosity. The first true antibiotic came from a fungus. In 1928, Alexander Fleming noticed that a mold called Penicillium notatum had killed bacteria growing on a petri dish in his laboratory. This accidental observation led to penicillin, the first widely used antibiotic. It went on to save millions of lives during World War II and reshaped medicine forever. Though not a mushroom in the traditional sense, penicillium belongs to the same fungal kingdom, once again revealing how deeply fungi are woven into human survival. What changed the course of medicine did not come from a grand invention, but from a quiet mold growing unnoticed. Inside that fragile colony was the power to turn deadly infections into treatable conditions, reminding us that fungi are not only recyclers of forests, but silent guardians of humanity. Fungi also make bread rise and wine ferment. Every loaf that lifts in the oven and every glass that sparkles at dinner owes its existence to fungi. Yeasts, single-celled relatives of mushrooms, feed on sugars and release carbon dioxide and alcohol. In bread dough, those gases stretch the gluten into soft bubbles, slowly inflating the loaf. In wine, that same process transforms grape juice into something richer and deeper. A sourdough starter becomes its own living ecosystem where yeasts and friendly bacteria respond to temperature, time, and flour. Bakers learn to sense its condition by smell and sound, a faint hiss like a quiet tide. Winemakers speak of terroir not only in soil and climate, but also in microbes, the invisible yeasts that shape flavor. Fermentation is chemistry, but it is also choreography, fungi guiding sugars toward nourishment and celebration one invisible breath at a time. Mushrooms have inspired entire worlds of art, from folk embroidery and illuminated manuscripts to modern design and photography. Their forms have captivated human imagination. Their shapes feel architectural, domed caps, ribbed gills, like vaulted ceilings, stems rising with balanced grace. Art Nouveau borrowed their curves. Botanical artists chased their subtle colors. Ceramicists glazed caps with rain softened shine. Designers echo their geometry in lamps domes and screens. Photographers crouch low to capture glowing caps at night, turning forests into constellations. Even children's stories return to mushrooms as symbols of surprise and hidden worlds. Their appeal is not only visual, mushrooms bay emergence. The idea that something extraordinary can appear suddenly when conditions are right. They feel both alien and familiar, inviting us to look closer. Some mushrooms may even produce faint sounds. Fungi have no mouths yet. Sensitive instruments have detected tiny, clicking signals as mushrooms grow and mycelium shifts fluid and pressure through its tissues. Whether these sounds are intentional communication or simply mechanical releases remains uncertain, but the effect is intriguing. Beneath the forest floor, electrical pulses travel through mycelial threads, speeding up and slowing down in rhythmic patterns. Some researchers and artists translate these signals into sound creating ambient music that responds to moisture, light, or touch. Listening to these interpretations, it becomes easy to imagine a quiet chorus beneath the soil coordinating growth and response. Whether language or byproduct, these rhythms remind us that living systems have tempo, and the rhythm of fungi is slow, steady, and precise. Some fungi live inside rocks, in deserts so dry that wind scours the land to bone. Life retreats into stone. Endolithic fungi slip into tiny mineral pores, living where temperatures swing wildly and water arrives rarely. In Antarctica's dry valleys, they inhabit translucent quartz, capturing faint, filtered light that penetrates only millimeters deep. Their chemistry is efficient and ancient. Acids dissolve minerals, pigments shield radiation, and metabolism slows to a near standstill until meltwater appears. These organisms do not rush. They write their existence in microns, patiently reshaping geology over time. Split a stone, and you may find not emptiness, but a hidden city of filaments. Life, in its most resilient form, does not always expand outward. Sometimes it survives by going inward, and sometimes fungi take control of animals. Certain mushrooms can turn ants into what appear to be zombies. An ant wanders beneath a leaf, and a single fungal spore lands on its body. The fungus grows inside the ant, eventually influencing its behavior, forcing it to climb to a precise height and clamp its jaws onto vegetation. There the ant dies, fixed in place, while the fungus erupts from its body and releases spores onto the forest below. The process is chilling, but it reveals how finely tuned fungal strategies can be. These organisms do not move quickly or loudly, yet they manipulate chemistry, behavior, and environment with astonishing precision. Through medicine, food art, soundstone, and even the other creatures fungi show again and again that they are not simple background life. They are engineers, chemists, collaborators, and survivors. Quiet, persistent, and endlessly adaptable, they shape the world in ways we are only beginning to notice. Inside the host, the fungus advances quietly, more like a chemical suggestion than an invasion. It threads through muscle and tissue while leaving the brain intact just long enough to guide behavior. Under this influence, the ant begins its final journey, climbing to a height that offers the best chance for dispersal. There it locks its jaws onto a leaf vein in an irreversible grip and becomes still. What follows is precise and unsettling. A fruiting stalk breaks through the exoskeleton like a dark bloom releasing spores onto the forest path below. This is the story of the so called zombie ant, a process as methodical as a clock and yet deeply uncanny. It feels like horror, but it is simply evolution refined. Nature does not judge, it calculates. And in this case, calculation looks like choreography: a climb, a bite, a pause, then release. Cordyceps fungi carry this strange elegance further. They erupt from insects' bodies, transforming small lives into sculptural moments. A caterpillar stiffens into a pedestal. A beetle becomes the base for a slender orange spear. A spider, frozen mid motion, sprouts delicate antler like growths. Each species of cordyceps is exquisitely specialized, evolved for a single host through millions of years of intimacy. Beneath the surface, enzymes soften tissues. Chitin threads fill hollow spaces. The insect's body is slowly remapped from the inside until the fungus emerges to fruit. The sight unsettles because it blurs boundaries we prefer to keep separate. Animal becomes structure, parasite becomes gardener, yet cordyceps also returns nutrients to the forest and keeps insect populations in check. An ecological balance written in forms that feel eerie only because we are not used to seeing them. To encounter one is to feel both repulsion and awe, and to remember that survival does not always wear gentle shapes. Elsewhere on the forest floor, some mushrooms appear playful instead of grim. In damp leaf litter, you might notice cups no larger than a fingernail, each holding what look like tiny eggs. These are bird's nest fungi. The eggs are not eggs at all, but packets of spores perfectly engineered for rain. When a drop strikes the cup at the right angle, it flings the spore packets outward like stones from a sling. A sticky filament helps them cling to passing twigs or fur, hitching a ride to new ground. It is physics rendered at miniature scale. Impact trajectory adhesion. Easy to overlook until you have seen it once. After that, the forest seems suddenly full of nests, entire nurseries operating silently at ground level. Bird's nest fungi collapse whimsy and engineering into the same small space. A fairy tale form executed with mathematical precision. Each rainfall becomes a signal for dispersal. Other mushrooms feel more somber. In shaded places, blunt black shapes rise from the soil like fingers half remembered. Dead man's fingers, xylaria, polymorpha, begin blue-gray and darken with age. Nearby coral fungi lift pale, branching structures like fragile chandeliers. These shapes feel intentional, almost gestural, as if reaching or beckoning, but they are simply fruiting bodies shaped to release spores efficiently into moving air. The names are ours, not theirs. They reflect our habit of seeing ourselves everywhere. If you look longer, the drama fades. Dead man's fingers are wood recyclers emerging from buried roots, marking where a tree once stood. They rise weather and crumble back into husks. Beneath them, the mycelium remains persistent and unseen, continuing its slow work with the patience of stone. It offers a quiet lesson. Much of what truly matters can remain unseen and still be the most faithful part of the story. Mushrooms understand this well. Some are coated in slime, their caps gleaming as if brushed with resin or rain. Certain species are so slick they seem almost polished. This sheen is not decoration, it is function. In boletes and slippery jacks, the viscous surface helps hold moisture and shields delicate tissue from drying winds. In stinkhorns, the slime takes on another role entirely. Thick, foul, and sweet, it imitates decay. Flies are drawn in land feed and depart carrying spores clinging to their legs like powder, a transport system powered by deception. To us, slime feels like a warning. To mushrooms, it is a toolkit, a raincoat, a moisturizer, a lure, a billboard. When your fingers come away tacky, it is a reminder that the forest favors usefulness over appearances. Even gloss has a purpose. At times, mushrooms abandon subtlety altogether. Some blaze with color so vivid it feels unreal. On certain mornings, the forest seems to forget its usual browns and greens. Indigo milk caps stain the ground with deep blue. Amethyst deceivers scatter violet flashes among fallen leaves. Wax caps rise in sherbet pinks and citrus yellows across old meadows. These colors are not chosen for beauty alone. Pigments can protect against light, act as antioxidants, or emerge as byproducts of chemistry tied to survival. To encounter a bright blue mushroom is to feel a momentary disbelief, like spotting a tropical fish in a forest puddle. Photographers wait for these encounters. A cobalt cap under moss, a purple stem against rust-colored oak. Color in fungi is a mixture of strategy and coincidence that reads as wonder to human eyes. The palette reminds us that forests are not monochrome. They are stained glass laid flat, lit from above by clouds, and painted from below by the quiet chemistry of soil. Even where life seems impossible, fungi endure. In the harsh stillness of deserts, where plants shrink into thorns and animals retreat underground, mushrooms persist. Some live hidden within rocks protected from wind and sun. Others form lichens partnerships with algae or cyanobacteria that spread like living skins across stone. The algae harvest sunlight. The fungi provide shelter and moisture. Together they survive where neither could alone. In the Atacama Desert, among the driest places on Earth, scientists have found fungi clinging to salt crystals and mineral seams surviving on rare fog and fleeting dew. They tolerate extremes of heat cold drought and radiation. Their resilience is profound. Through fungi, life whispers, even in landscapes we call lifeless, showing again that the edges of possibility stretch far beyond what we imagine. Long before humans walked beneath trees, mushrooms were already part of the world's great cycles. When dinosaurs thundered through prehistoric forests, fungi were there. They broke down fallen wood, recycled nutrients, and helped sustain the ecosystems giants depended on. Fossil evidence suggests mushrooms grew abundantly during the Cretaceous period, thriving in soils rich with decay. Some may have been eaten directly by herbivorous dinosaurs, plucked from the ground alongside ferns and conifers. Others worked invisibly below, supporting root systems and keeping forests alive. Imagine a massive sauropod stepping through a swampy clearing, the earth beneath dotted with broad capped mushrooms. In a world before flowering plants, fungi were already maintaining balance. They were both food and foundation. To realize that creatures of immense size relied on something so quiet is to understand how power rests on patience. The fossil record shows fungi reaching back more than 400 million years. They have watched continents drift, climates shift, and entire lineages rise and vanish. Through it all, they remained, recycling, supporting, waiting. Long before forests reached for the sky, fungi were already shaping the ground beneath them. The fossil record is crowded with bones and shells, with hard remains built to last. Mushrooms leave behind something far more fragile. Their bodies are soft, fleeting, easily erased by time. And yet traces of fungi still reach back astonishingly far. Scientists have uncovered impressions and mineralized remains of fungal filaments and spores dating back more than 400 million years to the Devonian period. These ancient traces reveal that fungi were already active on land at a time when life was only beginning to experiment with leaving the water. Some of these fossils preserve early mycorrhizal partnerships, fungi intertwined with primitive plants, helping them draw nutrients from bare rock. Even then, fungi were collaborators, pioneers, quietly preparing soil where none existed before. To hold a piece of stone bearing the shadow of a fungus that lived before forests, before flying insects, before most animals walked on land, is deeply humbling. These fossils remind us that fungi were not minor participants in Earth's story. They were architects present at the very foundation of life on land. Even more astonishing, the oldest known fungal fossil may be nearly 1 billion years old. In the Canadian Arctic, researchers discovered fossilized networks of microscopic filaments preserved in ancient shale dating back hundreds of millions of years before plants appeared. This places fungi among the earliest complex multicellular organisms ever identified. Long before forests cast shadows, long before animals evolved recognizable forms, fungi were already weaving networks, recycling nutrients, and reshaping their environments. These ancient fungi lived in a world utterly unlike ours, with different atmospheres, oceans, and continents. And yet their descendants still rise quietly today in gardens, forests, and fields. Every mushroom you see is connected by lineage to those primordial pioneers, carrying within it a memory of a planet still learning how to live. When mushrooms fruit, they sometimes arrange themselves in patterns so precise they seem intentional. Perfect circles, sweeping arcs, gentle spirals etched across grass and soil. These shapes emerge naturally from the way mycelium grows underground. As the network expands outward, it consumes nutrients at its center and pushes forward at the edges. Mushrooms appear along this advancing boundary, tracing geometry across the landscape. From above, these formations can look like diagrams drawn by an unseen hand. Spirals echo the mathematics found in shells and sunflowers, where efficiency shapes form. Circles spread year by year, widening slowly, marking the steady breath of the fungus below. To encounter such a pattern in a meadow is to glimpse hidden order rising briefly to the surface, beauty born not of intention, but of process. Physics, chemistry, time, and growth quietly collaborating. Not all spores rely on the wind. Some are designed to travel by touch. Their surfaces are spiked sticky or hooked built to cling to the legs, wings, or fur of passing insects. Flies, beetles, and bees become unwitting couriers, carrying spores far beyond what drifting air alone could achieve. Certain fungi sweeten the deal, offering sugary secretions or glowing signals that lure insects closer. Others position themselves on leaves and flowers where pollinators are guaranteed to brush past. It is a simple strategy, elegant and efficient. Why scatter blindly when you can recruit travelers already moving through the world? For the insect, nothing is noticed. For the fungus, survival expands with every flight. The forest hums with these silent exchanges. Movement becomes currency, and spores ride on wings like quiet passengers, trusting chance chemistry and curiosity to deliver them somewhere new. Fungi are famous for breaking things down, but they are just as important for holding things together. As mycelium spreads through soil, it binds particles into stable structures, preventing nutrients from being washed away by rain. This underground web acts like a living sponge, trapping nitrogen, phosphorus, and carbon where plant roots can reach them. In forests, this invisible support system maintains fertility and balance. Without fungi, nutrients would leach quickly from the ground, leaving soils thin and exhausted. With them, ecosystems gain memory and stability. Each thread of mycelium is both recycler and guardian, breaking down the past while securing the future. Beneath every healthy forest lies this quiet architecture, woven patiently, grain by grain, keeping the earth alive and ready for what grows next. Even in agriculture, fungi quietly perform this same task, protecting fertility beneath our crops. Beneath fields of wheat, corn, and rice, fungal networks help keep nutrients stable and accessible, preventing them from being washed away or locked beyond reach. You can imagine this underground web as a careful steward, gently tucking nutrients into hidden pockets, releasing them only when roots are ready to receive them. In this way, fungi are not only recyclers, but guardians, invisible custodians of soil health, preserving balance so fields can remain productive year after year. Without them, richness would fade quickly from the land. With them, fertility endures. Fungal networks also create entire transportation systems for microscopic life. Mycelium is not only a pathway for fungi themselves, but a shared infrastructure for bacteria and other microbes. Research has shown that bacteria travel along fungal threads, like cars on highways, using the filaments as stable roots through the complex maze of soil. In return, some bacteria provide nutrients protection or chemical assistance to the fungi, forming small but powerful alliances. Together, they build an underground world of roads, junctions, and exchanges. Without fungi, many microbes would remain isolated in tiny pockets of earth. With them, the soil becomes a living city busy with movement and trade. What appears to us as simple dirt is in truth a thriving metropolis engineered by threads finer than hair. Some mushrooms carry scents that feel surprisingly familiar. Lift the cap of a fresh field mushroom, and you may notice a warm, comforting aroma that instantly recalls freshly baked bread. This scent comes from volatile compounds similar to those produced by yeast during fermentation, linking forest fungi to the chemistry of baking. For foragers, the smell can serve as a clue, a quiet sensory signal of identity. But the fragrance is not meant for humans alone. Aromatic compounds help attract insects and animals, increasing the chances that spores will be brushed, carried, and spread. To encounter the smell of bread deep in the woods feels uncanny, as if the kitchen and the forest briefly overlap, reminding us that cultivated life and wildlife share deeper roots than we often realize. Other mushrooms release fragrances more commonly associated with spice cabinets than forest floors. Some smell distinctly of cinnamon, others of anise or licorice. These scents arise from chemical compounds nearly identical to those found in the spices themselves. Walking through damp leaf litter and suddenly catching the aroma of warm spice can feel almost surreal. Yet, for the fungus, the scent is not decoration, it is communication. These compounds can attract helpful insects or discourage hungry predators. Mycologists often rely on smell as a diagnostic tool, kneeling close to inhale the unique chemical signature of a species. Each aroma becomes a note in the forest's invisible orchestra, proof that fungi are chemists as much as decomposers, shaping the air with molecules that linger quietly in memory. Mushrooms are also remarkable reservoirs of water. After rainfall, they can swell dramatically, sometimes doubling in weight overnight. Their tissues are built from chitin and specialized cells that absorb and retain moisture with, with extraordinary efficiency. This allows mushrooms to appear suddenly after storms rising from soil and leaf litter as if summoned by the rain itself. The hidden mycelium stores energy patiently underground, waiting for moisture to unlock rapid growth. What looks like sudden magic is the result of long preparation. When conditions align, water floods into the structure, caps unfurl, stems lift, and the forest floor changes almost overnight. Mushrooms are reminders that much of nature's drama happens slowly in secret until a single night of rain brings it briefly into view. But the water mushrooms gather is not meant only for themselves. The moisture they absorb is released slowly back into the surrounding soil, softening the ground and creating gentle pockets of humidity where insects shelter moss spreads and seedlings take hold. In this way, mushrooms function like living reservoirs, quietly regulating moisture in the forest. What begins as a survival mechanism becomes an act of quiet generosity. Rain is captured, held, and shared. Each mushroom is more than a fleeting fruiting body. It is a vessel that remembers rainfall and returns it patiently to the living web around it, feeding the rhythms of the forest long after the storm has passed. Some fungi carry light within them for days at a time. Bioluminescent mushrooms glow with a soft green hue in the depths of darkness, their light steady rather than fleeting. Unlike fireflies, which flash and vanish, these fungi can shine continuously for days or even weeks. The glow comes from a delicate chemical exchange between luciferin and luciferase, the same family of reactions found in other luminous life forms. Scientists believe this persistent light may attract insects at night, helping spores travel farther than wind alone could carry them. Imagine walking beneath a rainforest canopy and seeing faint clusters of glowing mushrooms beneath ferns like embers resting on the forest floor. The light is calm and unwavering, a reminder that life continues its quiet work even while the world sleeps. Long ago, travelers called this foxfire or fairy fire stories, born from rotting logs that glimmered in the dark. Today, we understand the chemistry, but the wonder remains. It feels as though the earth itself is breathing light into the night. Across human history, mushrooms have held ceremonial and spiritual meaning. For thousands of years, cultures around the world have woven fungi into rituals of healing, initiation, and transcendence. In Mesoamerica, the Aztecs spoke of sacred mushrooms as the flesh of the gods used to bridge the human and divine. In Siberia, shamans consumed the striking red and white Amanita muscaria seeking visions and altered states. Indigenous traditions in Africa, Asia, and the Americas incorporated mushrooms into rites tied to fertility healing and wisdom. These cultures sensed something liminal about fungi beings that exist between growth and decay, light and shadow, the visible and the unseen. Even today, mushrooms continue to appear in modern spiritual practices and medical research studied for their potential to ease anxiety, depression, and deep existential fear. Across continents and centuries, they have never been merely food or poison. They are symbols of mystery, transformation, and the thin boundary between worlds. Some mushrooms do not wait for wind or rain to spread their spores. Instead, they launch them. In species like inky caps and puffballs, pressure builds inside the fruiting body until spores are released in sudden smoky bursts. Others, such as the remarkable Pilobolus, take this strategy even further. They construct microscopic chambers that build intense internal pressure, then release it all at once, firing spores several meters through the air. The force is precise and astonishing, invisible to the naked eye, but under a microscope it looks like a miniature explosion, spores arcing outward like tiny fireworks. It is physics, harnessed by biology, timing, perfected by evolution. In silence and darkness, mushrooms turn stored energy into motion, sending the next generation flying toward places they have never been. This method ensures that spores escape the shadow of the parent, reaching open ground where they have space to grow. When viewed at the scale of fungi, the forest is anything but still. It is alive with invisible launches, bursts, arcs, and leaps. Clouds of spores rise, fall, and drift endlessly through the air. What appears quiet to human senses is in truth constant motion, a ceaseless rain of possibility moving through unseen currents, carrying forward moment by moment. The fastest movement ever recorded in living biology belongs not to an animal, but to a fungus. Speed records usually conjure images of sprinting cheetahs or the lightning strike of a mantis shrimp. Yet the title belongs to Pilobolus, a tiny fungus that grows on animal dung. It launches its spores at speeds exceeding 20 meters per second, with accelerations rivaling a bullet leaving a gun. Inside its microscopic structure, pressure builds until it releases in an instant, catapulting spores with astonishing force. For a fungus barely visible to the eye, the distance traveled is extraordinary, sometimes more than 2 meters, over 100 times its own height. This precision ensures the spores land on fresh grass, ready to be eaten by grazing animals and carried onward. It is a quiet reminder that the most extreme power in nature often hides in the smallest, most overlooked places. Some mushrooms seem to borrow their shapes from the sea. Coral fungi rise from the forest floor in branching forms that mirror underwater reefs, pale white, golden, or glowing orange. They fork and twist like frozen waves, as though ocean life has wandered inland and taken root among leaves. These shapes are not accidents. Branching structures maximize surface area, allowing spores to disperse more efficiently into the air. But to human eyes, they appear as sculpture. Antlers, flames, coral towers form not by intention, but by growth itself. The same patterns repeat across ecosystems. Corals beneath the sea and fungi on land follow shared geometries written deep into the logic of life. To encounter them is to glimpse a design language older than forests or oceans, quietly repeating itself wherever growth is allowed to unfold. Other mushrooms resemble tiny umbrellas scattered across damp ground. After rain, delicate caps rise in meadows and woodlands thin as parchment and sometimes translucent in the light. Many live only a day or two before collapsing back into the soil. Their lives are brief, yet unforgettable. The cap shelters spore-bearing gills below, while the stem lifts them just high enough to meet passing air. It is a form both practical and poetic. This simple silhouette has become the universal symbol of mushrooms themselves. Children draw it instinctively. Fairy tales decorate it with spots. Scientists analyze its mechanics. In its elegance and impermanence, the parasol-shaped mushroom captures the spirit of the fungal kingdom. Fleeting, precise, and perfectly adapted to the moment, fungi may hold an important key to capturing carbon from the atmosphere. As the planet warms, scientists search for ways to draw carbon dioxide back into the earth. Mycorrhizal fungi, which live in partnership with trees, may already be doing exactly that. These networks channel sugars produced by plants deep into the soil where carbon can remain locked away for centuries. Some fungi create compounds that resist decay, slowing the return of carbon to the air. Researchers are now studying how fungal systems could be encouraged to strengthen this natural process, turning forests and soils into more powerful carbon sinks. Imagine confronting climate change, not only with machines and technology, but with living networks beneath our feet, quietly weaving excess carbon back into the ground. In the patient labor of fungi may lie one of our most understated allies. Looking beyond Earth, fungi may even help shape life on other planets. If humans one day attempt to colonize Mars or distant worlds, mushrooms may travel with us. Their resilience, adaptability, and ability to recycle waste make them ideal pioneers. Fungi could help transform sterile soil into something fertile, breaking down rock storing water and creating the first foundations for ecosystems. They might recycle human waste, produce food, and shield settlers from radiation. In the cold silence of another planet, fungal networks could become the first living threads to stitch together a new environment. Long before trees or animals arrive, fungi may once again play their ancient role, preparing the way, patiently transforming barren ground into the possibility of life. Their durability makes fungi strong candidates for shaping life beyond Earth. They can break down rock into soil, grow food from waste, and recycle nutrients inside sealed environments where nothing can be lost. Some species tolerate radiation, extreme cold, and low gravity qualities that make them valuable for future life support systems in space. Mycelium itself can be grown into structures light yet strong, biodegradable, and resilient, forming walls, insulation, or shelter without factories or heavy machinery. Scientists now imagine fungal biodomes, habitats not assembled piece by piece, but cultivated slowly, expanding like living architecture. This vision mirrors Earth's own deep past, when fungi prepared barren land for plants hundreds of millions of years ago. They were pioneers once, and they may become pioneers again, carrying ancient skills into unfamiliar worlds. If humanity ever moves beyond Earth, it may not travel alone. Fungi could once more lay the foundations, quietly weaving new ecosystems, just as they did here. Without fungi, life on Earth would unravel. Remove them from the planet, and forests would drown in their own fallen leaves. Nutrients would wash out of soil. Cycles of decay and renewal would stall. Most plants would struggle to survive without fungal partners to help them absorb minerals and water. Without plants, animals would vanish. Even the balance of oxygen in the atmosphere depends on ecosystems sustained by fungal networks. Fungi are recyclers, collaborators, healers, and silent engineers. They work unseen, yet their absence would be catastrophic. Every meal we eat, every breath we take, every green landscape we admire exists in part because fungi are there quietly maintaining balance. Mushrooms are not background characters in the story of life. They are part of its foundation. Without them, the stage would remain empty, and the drama of living systems could never begin. And so our gentle journey through the kingdom of mushrooms comes to rest. From glowing lights hidden in forest darkness, to spores drifting unseen above cities, to networks older than trees themselves, we've explored a world that is both hidden and essential, delicate and enduring. Mushrooms remind us that life does not always announce itself. Much of the planet's work happens in silence beneath our feet, carried out by threads so fine they slip through stone. Fungi teach patience, resilience, and transformation. They turn decay into nourishment, store water for dry times, feed giants and insects alike, and carry quiet messages between plants through underground webs. Without them, there would be no bread rising in ovens, no forests reaching toward the sky, no steady rhythm to Earth's cycles. As these ideas settle, imagine the slow pulse of mycelium beneath you, a calm heartbeat of the soil. Picture spores drifting like fine dust through the air, carrying possibility everywhere they land. See the soft glow of mushrooms in the night, small beacons reminding us that even in darkness, life continues. This is the comfort of science told slowly, a reminder that the world is stranger, richer, and more connected than we usually notice, and that when we pause long enough, the ordinary reveals something extraordinary. If you've enjoyed this quiet exploration and would like to wander through more worlds of curiosity and calm, you're welcome to subscribe, or share a thought below. It helps this small community of dreamers and science lovers continue to grow. But for now, there is nothing you need to do. You can let the story of mushrooms fade like evening light, leaving only stillness behind. If sleep arrives, allow it to carry you gently. If you remain awake, you're welcome to stay to listen again or to continue your journey into the quiet wonders of the universe. Rest well, and remember the world is full of hidden marvels. Some rise overnight, like mushrooms after rain. Others have been waiting patiently beneath the surface all along. Good night.